So for 8.3 through 8.6, we're going to be solving square roots. And I typically don't say the word square. From now on, it'll be roots, because sometimes it's a cube root, sometimes it's a fourth root or a fifth root. But solving for roots, and then quadratics, which we've been doing some factoring of so far. We're going to be rationalizing fractions, and I'll explain what that means when we get there. And then at the end, we're going to be doing completing the square again, because it's a very important tool that we're going to use now. And if you take pre-calc next, in pre-calc we'll do a lot of completing the square. But we're going to start with this idea, and more just thinking conceptually, because in this case you say, well, when is this function less than 0? When we have, now we're not going to solve this right now. We will get to a place where we'll eventually solve this. But it's more of a conceptual way of saying, well, when is that graph, x over x minus 4, going to be less than 0? And I have a fraction with two things. So what I'm going to do instead is I'm going to kind of do a little, oh, my pen is turned off. If I have like something divided by something, and it's less than, turn that back. And if it's less than 0, if I have two things divided and it's less than 0, what do you know about one, like either the numerator, the denominator, or both? So when we're considering this, we know that either the numerator is less than 0, so it's negative, and then the bottom is positive, or it's going to be a positive over a negative. Either way. So then I look at this and say, okay, now let's think about this. If I look at the numerator, and my numerator is x, and I want my numerator to be negative, what must x be? Now the top one's kind of easier, but sometimes when it's just like the simple one and only thing, people get a little confused, like, wait, what? What makes x negative? Well, I have x right now, just all by itself, that's just the numerator. X is negative when, x is negative when x is less than 0. All right, because that's what negative means. Now, if the top is negative, that means I need my bottom to be positive. So then I say x minus 4 is positive when x minus 4 is greater than 0, because that's what positive means. And then we solve it. Now, the top one's already solved right here. X is less than 0. So here, this is positive when this is greater than 0. So where does that happen? That happens, well, if I add 4 to both sides, that happens when x is greater than 4. So then I go, okay, so in order for this whole thing to be negative, x needs to be less than 0, and x needs to be greater than, oh, that's not a 4. Right? I added 4 to both sides. X must be greater than 4 if I add 4 to both sides. So then look and say, okay, when is x less than 0 and greater than 4? And that's not a trick question. It's tricky, but the answer is it's never going to happen. When can x be less than 0, x is a negative number, and x is greater than 4, a positive number? The answer is never. So this equation itself will never be less than 0. And what we're going to be doing is developing a sense for, as I look at equations, trying to think through what is this going to mean graphically when I'm doing this. All right. So, and you can try certain numbers in there if you want. If you don't believe that, say, okay, well, what if x is 0? I would have 0 divided by, okay, 0 minus 4 is negative 4. 0 divided by negative 4 is 0. So it equals 0, but that's not less than 0. If I put in a positive number, 1. Now, unless we did this incorrectly, so if this is negative, x is less than 0, this needs to be positive because of negative by a positive. So if I put in a 1, and then 1 minus 4, well, wait a second. So now I have 1, which is positive. I have 1 minus 4, which is negative. And 1 over negative 3 is less than 0. So then we got to look at the other option, say, well, so it can't happen this way. Maybe it'll happen this way. So then I redo the problem down here. All right. I need the numerator to be positive, so I need x, which is my numerator from up here, to be greater than 0. When does that happen? Well, it happens when x is positive. The bottom needs to be negative, so I need x minus 4 to be less than 0. Add 4 to both sides. X is less than 4. Just add both sides. So now I have x is less than 4 and x is greater than 0. Can you have a number that's both greater than 0 and less than 4? Oh, now I can. And if I think about a number line, 0, and I say greater than, so I'm going up this way. 4, less than, going left, open dots. This equation is negative when x is between 0 and 4. But from less than 4, which is this part, and greater than 4, which is this part out here, it is not negative. So out here and out here, it's not going to be negative. Well, we call things that are not negative, we call them positive. So I have a graph that will be positive in this area, negative in this area, back to positive in this area. But we're really thinking as we started this whole process, which we'll do a couple more of these, in order for this whole thing to be less than 0, it's either negative over positive or positive over negative. The first one we tried didn't work. Don't get frustrated and say, oh, it's not going to work. Do the bottom one, because it's either this or that. So what I want you to do is take a moment, see if you can figure this one out. A little bit different because now my sign is greater than or equal to 0. So I want this whole thing to be greater than or equal to 0, which means I want it to be either 0 or a positive number. So take a moment, write that down, see if you can figure that out, and then hit the video off of pause, and we'll go through a solution. All right, so as we're working through, we're thinking, how do we know that this whole fraction is positive? That means I need both the numerator and the denominator to either be both positive or both negative. So I'm going to start with both positive. So I'm going to start with positive over a positive, which means I need x plus 2 to be greater than 0. Well, greater than or equal to 0. And I need x minus 3 to be greater than 0. Now, I didn't say greater than or equal to 0, and that's a really big point that I want to make here that you are going to want to always pay attention to. A denominator fraction can never have 0 in the denominator. If I have 0 in the denominator, I'm asking 0 times what number gives me the numerator? And the answer will be nothing, because 0 times anything is always 0. If you use calculators, depends on the type of calculator you have. It'll either have, if you do like a graphing calculator, error domain mismatch. If you have just an old school calculator, it'll say error. Or some of them might actually give you an empty set symbol. It depends on the type of calculator you have. But you cannot divide by 0. The reality is you say, well, how many zeros? So dividing as it goes into, how many zeros go into the top? How many zeros go into 2? Well, all of them. Every 0 that exists in the universe can go into 2, and I'll still have 2 left over because 0 has no value. So you cannot divide by 0. So the denominator can never be equal to 0. So when I go back to solving, then I'm going to go, all right, then I'm going to subtract 2 from both sides. X is greater than negative 2. And then over here, I'm going to add 3 to both sides. X is greater than 3. Can I be greater than or equal to negative 2 and greater than 3 at the same time? And if you're not sure, plot a little number line, negative 2, closed dot, greater than. Then I'm up here at 3. This is coming up. I'm at 3, open dot. And then I keep going up. Oh, so I am shaded from both of them in this area. So my function up here will be positive when x is greater than 3. So far, that's part of when my graph is going to be positive. But then I need to check, well, what happens if I have a negative divided by a negative? So I have x plus 2 less than 0 and x minus 3 less than 0. Subtract 2 from both sides, x less than negative 2, and then add 3 to both sides, x is less than 3. Can I be, and this is less than or equal to, can I be less than or equal to negative 2 at the same time that I am less than 3? Well, less than 3 is from here down. Less than or equal to negative 2 is from here down. So the space that's double shaded in yellow is this area, which is x less than or equal to negative 2. The space that was double shaded in white was this area up here, which was x greater than 3. So the answer to this question is this equation up here, to use set notation. I have this one and this one that I'm going to rewrite into set notation. And the one that starts with the negative, it goes from negative infinity up to negative 2. And I look down here, and it's less than or equal to 2, because this is a greater than or equal to, so it can also be less than or equal to. So it will equal negative 2, which means I use a bracket there. And then I also am x greater than 3, and that will happen at 3. And then greater than means it goes up to positive infinity. And that's parenthesis, not bracket, because this is greater than. Because if this equaled 3, and this is always go back and look at the equation. If this equaled 3, 3 minus 3, I would have 0 in the denominator, which I cannot ever do. I will explode, implode, math ceases to exist, which some of you might like that idea. But x cannot be 3, which is why it's a parenthesis, not a bracket. So I've got set notation, which represents these two ideas. So when is this equation greater than or equal to 0? Well, it's either when x is less than or equal to negative 2, so way down here in the negative world, or from on my number line at negative 2 down below, or when they're both positive, and that occurs when x is greater than 3. But between negative 2 and positive 3, one of these is going to be negative. And if one of them is negative and the other one's positive, then I'm dividing and I get a negative number, so it would not be greater than or equal to 0. All right, so now pause again, work this problem, which is very similar to this one, except that we just switched the signs, so it shouldn't be too hard. Work through that quick, so hit pause, work through it, and then we'll go through a solution super fast. Moving right along, we have this whole thing, the whole fraction, again, we're thinking this whole, one whole thing divided by another, it's less than 0 whenever the top is positive and the bottom is negative, or the top is negative and the bottom is positive. So when the numerator is positive, the denominator is negative, I have a negative value, and vice versa. So I'm going to run it down as two separate ideas. So when the top is positive, that means x plus 2 is greater than or equal to 0, which means x is greater than or equal to negative 2. And then here I'll add 3, x is less than 3. So I have, this will occur when both of those things happen. When x is greater than 2 and when x is less than 3. Sorry, greater than negative 2, less than 3. And I try to think on a number line, can that happen? I'm at negative 2, closed dot, shading above. I'm at positive 3, open dot, shading below. Oh yes, that can occur when I'm between those two values. Then we look at the other one. We subtract 2, x less than or equal to negative 2. Add 3, x is greater than 3. can I be both less than negative 2 and greater than 3 at the same time? There, the answer is no. I cannot be a negative number and a positive number at the same time. So this does not exist. So this does exist. So my answer is that and that alone, which in set notation would be negative 2, bracket because it's closed dot, up to positive 3, open dot, which kind of makes sense because this one over here, when is it positive? It's positive from below 2 all the way up to above 3, but not in between. This one, it's negative when it's in between. On the left side, it included 2. On the right side, it also includes 2 because it'll be equal to, it equals 0 when x is negative 2. Negative 2 plus 2, that's 0 in the numerator. When 0 is in the numerator, the whole fraction is 0. 0 divided by any number is 0, unless the bottom's also 0. So just be careful. 0 over 0 is not 0. Well, or it is, or it's undefined, or some people even argue that it's 1 because anything divided by itself is 1. But 0 over 0 has no value, so anyways, it's more of a theoretical debate that we're not going to get into, which I think was a conversation topic from a discussion post about 4 or 5 weeks ago. Yeah. But 2 is included in both of these because it can be 0, which means whatever's going on with this graph, it crosses the x-axis at 2, or at negative 2. But it's over here on the left, my equation is positive, and then it equals 0. It's negative, and then it's not equal to 3, so there's like an open dot on the graph, and then it goes back to positive again. So my graph will be in the positive realm, then it'll be in the negative realm, and then it'll be back into the positives again. Now we're not going to graph this yet, but if we did, you would see, oh, I can see what's going on. It's up here, and then it's equal to 0, and then it's down below, and then it comes back up. This is I call it a review, but many times I get to this and people go, wait, what? I don't know what to do with this. We're thinking, can I factor that? Is the first thing something squared? And this is remembering our rules of exponents, and it actually is. It's p squared times p squared. P squared times p squared is p to the 4th. And then because my leading coefficient is 1, the number in front of the highest power is 1, I'm looking to say, are there two numbers that multiply to negative 4 that add to negative 3? So I'm going to have, let's see, it has to multiply to a negative, which means one of them is positive and one of them is a negative, just like we did on the previous questions where we're dividing. So one's positive, one's negative. Has to multiply to 4 and add to negative 3, which means the bigger one needs to be negative because the number inside is negative. So negative 4, positive 1, do those multiply to negative 4? Yes. Do they add to negative 3? Yes. Am I done? No. Because now, lo and behold, I have, as we've had many times, and I've said you will see it again and again, a difference of squares. I have this, which is also factorable as the difference of squares. What number multiplies to negative 4 and adds to 0, because there's no middle term? P plus 2, P minus 2, which you saw in the exam. I think there was like a b squared minus 25 in one spot. There was a x squared minus 16 on another problem. There was, I think, also an x squared minus 25 in another place on the equations. So it happened off the top of my head at least 3 times. There may be more. And p squared plus 1 cannot be factored. How do I know? Because no two numbers multiply to a positive 1 and add to 0. Because you might be thinking, well, p plus 1, p minus 1, but the plus and minus 1s would multiply to a negative 1. So we do not have a sum of squares special formula, but we do have a difference of squares. So this is the difference, subtraction of squares, p squared and 2 squared. This is the sum of squares, p squared and 1 squared, but there is no way to factor that. At this point, I would say that equals to 0. And then to solve, what makes this 0? P is negative 2. what makes this 0? P is 2. And then we ask what makes this 0, and if you don't know, you can always just say p squared plus 1 equals 0. Subtract 1 from both sides. P squared equals -1. And then we take the square root of both sides. And I have p equals the square root of -1. And that, my friends, is an imaginary number. The imaginary number I. The square root of -1 is defined as the imaginary number 1, or I. Square root of -1, imaginary number I. So not a real root. So this is a solution. This is a solution. This technically is a solution, but not in the real number system. And it would be plus or minus. Because I'm taking the square root of something squared. So that's a little bit of review there. We're going to do another one where, again, it looks like, wait, those are weird. But we're thinking, what are my properties of exponents? What number times itself is x to the 2/3? Well, that's x to the 1/3. Because, I'll do it down here, x to the 1/3 times x to the 1/3. When you have same bases and multiply, you add. So that's x to the 1/3 plus 1/3, which is x to the 2/3. All right. Now I need two numbers that multiply to a positive 6. So positive means both of the operators are either both positive or both negative. And the middle number tells me that they are both negative because they have to add to a -5. What numbers multiply to 6 that add to -5? 2 and 3. And that equals 0. And then I ask myself, how do I solve that? X to the 1/3, some people like to think about it like this, is the cube root of x minus 3 equals 0. Add 3 to both sides. Cube root of x equals 3. And then to solve the cube root, we cube both sides. X equals 27. I will do the same thing with this one. The cube root of x. And here, I'll do it with the fractions, just so you can see there's another way to go. X to the 1/3 minus 2 equals 0. Add 2 to both sides. X to the 1/3 equals 2. And then if I take powers raised to powers, which is what I'm doing, 1/3 times 3, this 1/3 times 3, because powers raised to powers, 3 1/3 is 1. That's how I get just x to the first power. Equals 2 cubed, which is 8. So my two answers are x equals 27 and x equals 8. If I were to go back and put either of them into this original equation, they would both simplify out and give me 0 as a final answer on that. So there's a couple more complicated ways of factoring. We're not going to see these that often, but when you do, realize there's probably a way. So now we're going to go with some fractions. This should be somewhat reviewish again. But let's look at that first set of fractions in my formatting. So this is one problem at the top. This is another problem right there. For some reason, they all kind of got jumbled there. But I've got 1/3 minus 2/3 equals x over 3. If I have a set of fractions and they all have the exact same denominator, I can simply look at the numerator only as its own separate equation. And I would have 1 minus 2 equals x, which means I have -1 equals x as a solution. It's similar to clearing out the fractions, which we've done in the past too, where some people say, well, if I multiply everything by 3, well then this multiplying by 3 to this fraction would reduce those 3's. This 3 multiplying to this fraction would reduce the 3's, leaving me in the negative 2. This 3 multiplying by this fraction would reduce the 3's, leaving me with 1, which is just what we have right there. So if I can get the exact same denominator, I can simplify faster. My common denominator here will be 15. And how do I get there? I multiply that first item by 5 over 5. I'll multiply my second fraction by 3 over 3. And I'll multiply the last fraction by 5 over 5. So here, and this is where some people go, wait, I'm not doing the same thing to both sides. Nope, I'm just multiplying each fraction by 1 so that it gets into a better looking form. And because I'm multiplying it by 1, I don't need to worry about what I do with the other fractions. This will be 5 over 15 minus 6 over 15 equals 5x. 5 times 1 is the 5. 2 times 3 is the 6. 5 times 3 is 15. 3 times 5 is 15. 5 times 3 is 15. 5 times x. So now I have, as an equation, 5 minus 6 equals 5x. Negative 1 equals 5x. X equals negative 1/5. And then my process will be essentially the same when I'm working with fractions, and now I've got variables in fractions, which means now my denominator, I see here is a 3, x, here's a 3, here's a 3, which means now I need my denominator to include an x. So I need to multiply this fraction by x over x, this fraction by x over x, and when I do that, I will have 1 minus 2x equals x squared. So here I've taken just a simple fraction where we started this slide, made a little bit more complex fraction, and now I have a quadratic. To solve quadratics, we set quadratics equal to 0. So I need to move plus 2x to both sides, and I'm going to subtract 1 from both sides. Here's my both sides. On the left, I now have 0. On the right, I have x squared plus 2x minus 1. Do I have two numbers that multiply to negative 1 and add to positive 2? The answer is no, I don't. So I'll get rid of my things, and this is when you would run it through the quadratic formula, which I'm not going to do on the slides right now. This is something we've done countless times. Actually, we probably could count them, but it's been a lot. And I'll let you figure that one out. So that way we can get to this problem here. So now I'm looking at this and realizing I have multiple things going on in my denominator. But this has an x, this has an x minus 2, this has both the x and the x minus 2. So this will be my common denominator. This fraction and this fraction need some manipulation. This one we're going to multiply by x over x. And this one is going to look sloppy here for a second. X minus 2 over x minus 2. 3x times x, 3x squared, minus, here I have x plus 1 times x minus 2, and this will equal 6. So again, as we're looking through there, in order to get x times x minus 2 as my denominator of this equation, or of this term, it needs to be multiplied by 1, x minus 2 over x minus 2. And then this one, in order to have x times x minus 2 as the denominator, it needs to be multiplied by x over x. 3x times x is 3x squared. And now I need to FOIL this. Biggest mistake I'll see people make is they'll forget to get this negative onto all the other terms moving forward. Anytime there's a subtraction, you need to pay very, very, very close attention. So what I typically do is I'm going to do this minus, and then I'm going to do my FOIL. X squared plus, sorry, come on, pen. All right, outside's negative 2x. Why is it not using use my pen? Negative 2x. Inside's plus x. Lasts negative 2. Bracket equals 6. So then I'll have these middle two terms will combine into a negative x. I'll just put it there as the white. So then I'll have 3x squared minus x squared, because it's negative times x, plus x, because it's negative times negative x, and then plus 2 equals 6. Combine like terms, 2x squared plus x. And then I'm going to move the 6 to the left-hand side because I need to set it equal to 0. I want this to be 0, so I subtract 6, so minus 4. And then I'm looking to see, can I factor that? Two x and x. One of them's positive, the other one's negative. I know that because it has to multiply to a negative 4. And then they have to add to 1, but I've got a 2 in the mix. So it'll be 2 times whatever this last term is. So I can try things like 2 and 2. So that would be 4x and 2x, the difference of which is not 1x, that's 2x. So it's not 2 and 2. What else multiplies to 4? 1 and 4. And that's not going to work because I'd have 8x and 1x. The difference is not positive 1. What if I did 1 and 4 this way? It's still going to be 2x and 4x. So again, I'm at a place where I can't do this by factoring. So what I'm going to do instead is I'm going to do completing the square. So I have 2x squared plus x equals 4. The first step in completing the square is to set it so that all of my constant values are on one side, variables on the other side. So if you have a process list somewhere of like, how do I complete the square? Because we're going to do more at the end of today too. Completing the square, you start by having your variables on one side, numbers on the other side only. And then I need to have my first coefficient, my first term needs to be 1. And my first term right now is 2 and for the x squared. So I'm going to factor the 2 out of it. And I need to factor it out of the 1 that's not written but does exist there in front of the x. So when I factor that out, it's a half x. This equals 4. And then typically, what I recommend folks do is go ahead and divide both sides by 2. So now I have x squared plus a half x equals 2. If I divide everything on the left by 2, the 2's reduce. Divide everything on the right by 2, I have 2. 4 divided by 2 is 2. Now procedurally, what I need to do is I need to take half of b. Half of b. Well, b is a half. So I need to take half of a half, which will be 1/4, half of a half. And then I square that number, which is 1/16. And I add 1/16 to both sides. And this gets to the idea of that our fraction, or excuse me, our equal sign is a balance. Whatever you do to one side of the equation, you absolutely must do to the other side. And now this is the sum of, it's a complete square. What does that mean? That means if I were to factor this, it would be, I want it to be white. There we go. X plus 1/4 parentheses squared. How do I know it's 1/4? Because that's half of the middle term. The middle term was a half, and I took half of a half, and that's a fourth. If I were to rewrite this out as x plus 1/4 times x plus 1/4, that's what squared means, and then FOILed it out, I would get this. And then over here I have equals 2 and 1/16, which you can leave as a mixed number. I typically write them as improper fractions. 16 times 2 is 32 plus 1. It's 33/16. Now, to solve for x, I need to get rid of parentheses. How do I get rid of parentheses? I'm like, well, what's going on to the parentheses? The parentheses are being squared. So allow me to rewrite this equation on another slide. X plus 1/4 squared equals 33/16. To solve for x, I need to get rid of that squared, so I'm going to square root everything, because everything on the left is being squared. I'm going to square root everything here, which can be rewritten as the square root of 33 divided by the square root of 16. On the left, I'll have x plus 1/4. On the right, I will have plus or minus the square root of 33 over 4. Square root of 16, we know that number is 4. Square root of 33, I don't. To solve for x, I need to subtract 1/4 from each side. So minus 1/4, minus 1/4. X equals negative 1/4 plus or minus the square root of 33 over 4. If you would do the quadratic formula, that is the exact same answer you would get. But it would probably look like, slightly differently, it would look like x equals negative 1 plus the square root of 33 over 4, once you've simplified. Here's another one that I'd like you to give a try on your own. I'm not going to do it on this slide right now, but I will tell you this. We need my denominator. My common denominator will be 3x times x plus 10, which means every fraction is going to have something that gets multiplied by. And I'm going to have some really big numbers in there. And that's okay, because once we get it done, take your steps, take your time, use FOIL where it's necessary. Set it up as a quadratic, because this will be a quadratic. You'll set the quadratic equal to 0. And I can't remember off the top of my head if this one can be factored or not, but we can always use the quadratic formula, or you can do completing the square using the same steps we did from the last one, or that you'll see with these later problems we're going to work on. So now we're going to go on to this. What if I have a square root? I've got 3 problems here. I've got this one. I've got the square root of x equals 3. I need to solve for x, which means I need to get rid of the square root. And since the only thing happening on the left side is the square root, I can square it, because squaring is the opposite of square rooting. So this first problem, we have x equals 9. Pretty quick, pretty easy. The next one over, slightly different, but similar. if I squared this whole side, and I'm going to show it to you, and I'm going to do it in red because it's bad. We're not supposed to do this. This does not mean x minus 9. Absolutely does not mean x minus 9. Because if you square it, I would have to write square root of 3, or square root of x minus 3, parenthesis, next parenthesis, square root of x minus 3. And if I did that and FOILed it, it would be x plus 2x root 3, or sorry, yeah, plus 2 root 3, 2 root x, plus 2 root x, and then it would be plus 9. It's not this. So in order to get rid of this, I do not square it first. Instead, I need to eliminate it and have a square root all by itself. How do I do that? By adding 3. And now it's the exact same as the other problem. Square both sides, x equals 9. So when dealing with your variable underneath the square root, if you like to think in terms of what are my steps? Steps are 1, isolate the root all by itself on one side, put everything else on the other side. And that might even mean we're putting other variables over there. We're not isolating the x. We're isolating the square root first. Let's take this one and move it down here. Square root of x minus 4 equals 2. Need to isolate the root all by itself, so add 4 to both sides. Square root of x equals 6. That's a 4, by the way. And that's an equal sign, not a minus. Square, because square eliminates the square root now, and I'll have x equals 36. Those are the ones that we always start with to say, okay, what do we do? How do we do it? Okay, that's the square root. We'll take that, we'll square it, we'll move on, and then we get to the more complicated looking ones like this. Again, first step, get all my roots, hopefully there's only one, all by itself on one side. If there is, then I will subtract 5 from both sides of the equation. And I'll be left with, on the left-hand side, with the square root of x minus 1. And that x minus 1, the minus 1 is under the square root. This will equal negative 3. What I also see for people that make mistakes, is then they're going to try to add 1 to this side. You can't do that. The square root, much like parentheses, traps things inside. The only way you can get rid of and move the 1 is if I can get rid of the square root first. So now, if I take this whole side and square it, this whole side and square it, then I'll have x minus 1. Since everything was being square rooted, if I square it, those are inverse operations. They eliminate one another. And on the right-hand side, negative 3 times negative 3, positive 9. Add 1, x equals 10. And then you can go back and check this. 9 minus 1, or sorry, 10. 10 minus 1 is 9. Square root of 9 is 3. 3 plus 5 is 2. Wait a second. I thought we wanted it to be something else. So when we did this, what happened? Oh, back up in this step. So although algebraically I did this right, what I ended up with is I want the square root of something to be negative 3, which doesn't exist. Although we could solve it algebraically, in this step right here, when we isolated or eliminated the square root, we needed to look over here and remember that if I square root any number, any real number, square root of any real number k, it will always be a positive number. I can't take the square root of it and get a negative, because the square root of 4 is 2. Square root of negative 4, well, I can't do that. You cannot get a negative number when you take a square root. So although algebraically I got an answer, I plug it back in and go, wait, oh, it doesn't work. Why not? Did I do something wrong mathematically? I did not. What I didn't do is I didn't remember that the square root of a number can never be a negative value. This one. Again, procedurally, first step whenever I have a square root is get the square, and my variable, let me say. If I have a square root with my variable under the square root, step one, get the square root variable all by itself. Add 2 to both sides. So I'll have square root of x equals x plus 2. Now, since my square root's all by itself, I can square that side to get x all by itself. And when I square the other side, I am squaring the whole side. Squaring means x plus 2 times x plus 2. Our desire is to get lazy and say, oh, it'll be x squared plus 4, and that's wrong. Every time that will be wrong. When we're doing binomials, 2 numbers, and we're squaring it, always write it out as x plus 2 times x plus 2. And then you're going to see that and go, oh yeah, FOIL. And then simplify. It would simplify to x squared plus 4x plus 4. So you can clearly see it's not x squared plus 4. It's x squared plus 4x plus 4. Now I have a quadratic. And then I go back to my next set of procedures. What do I do to solve a quadratic? I need my quadratic to equal 0, so I subtract x from both sides. 0 equals x squared plus 3x plus 4. Do I know 2 numbers that multiply to 4, positive 4, that add to positive 3? Darn it, I do not. So I'm going to very quickly run through, again, completing the square. Subtract 4 from both sides. Then I'm going to take half of the middle term, so half of 3, which is 3 halves, and then square it, and add 9/4 to both sides. I will have x plus 3 halves, parentheses, squared. That's why we did the completing the square, because I know that when I take half of b, half of 3, that'll be that value. On the left-hand side, all right, 4 is the same as 16/4. Just converting my fractions. So 9 minus 16 is negative 7/4. Equals that value. I now need to take the square root of that side. I need to take the square root of this side. And some of you should hopefully be looking at that and saying, wait, can I do that? Can I take the square root of a negative 7? No, I cannot. In this case, I would get to that place and realize, because I cannot root a negative value or a negative number, there are no real roots. There are no real roots. And yes, that's messy handwriting. I'm using my finger instead of my stylus. I apologize to everybody in advance on that one. But because I have my voice over speaking it, you can actually see what's being said. So I cannot take the square root of a negative number, so there are no real roots. If I did the quadratic formula back with this equation here, I would have ended up with a square root, and it would have been a negative number under the square root, and you would have got to the same place and said, because there's a negative under the square root, I cannot make and find a solution to this problem. Graphically, this would mean that my parabola, this parabola, x squared plus 3x plus 4, it opens up because this is a positive number. We're going to do a little bit more with parabolas here in a minute. And it will never cross the x-axis. How do I know that? Well, because there are no real roots. They're imaginary roots. Do another one. Let's see. Get my square root all by itself. My square root is being subtracted. So for my sake, I'm actually going to take that and I'm just going to move that whole thing over to the right-hand side. I'm going to add root 19 minus 2x to both sides. And when I do that, on the left, I will have x minus 2. On the right, I will have root 19 minus 2x. Now I have a square root. My variable under the square root is isolated all by itself on one side. I now can square it, and over here, square it. Out of habit, I realize on the left, x minus 2 squared is x minus 2 times x minus 2. And if you FOIL that, that's x squared minus 4x plus 4 equals 19 minus 2x. I have a quadratic. Procedurally, set it equal to 0. I want this side to be 0, which means I need to add 2x. I need to subtract 19. And now I just hope for hope, so I don't have to do the quadratic again or the completing the square again. Are there two numbers that multiply to negative 15 that add to negative 2? I think there actually might. Because I have x and x. I've got 5 and 3. They multiply to negative, which means they're opposite signs. One's positive and one's negative. The middle number is negative, which means the larger value must be the negative one. This is positive. This is negative. And do those add to negative 2? 3 plus negative 5 is negative 2. Yay, it factors, which is so much nicer and happier when we can do that. Which in a math classroom, we can do that often and make that happen. When you get to real world problems and doing quadratics to solve them, unfortunately, the world itself doesn't like to exist with factorable forms typically. But then I say, this equals 0, which means I have two things. I got this block times this block multiplying to get 0, which means either this is 0 or this is 0. Which means x is either negative 3, because if I put negative 3 plus 3, that's 0. Or x is 5, because I put 5 minus 5, so 5 in there. 5 minus 5 is 0. 0 times it doesn't matter, whatever that is. Those are my two solutions. Which means whatever that graph is that's going on with my original equation up there, it crosses the x-axis at two locations. Here and there. Now we're back to squareds. Solving. It's just like going with x back in the day. Going to add 4. X squared equals 4. X equals plus or minus 2. How do we remember this, Mr. Steffen? How do we figure this out? Why do we know it's plus or minus? Whenever I take the square root, because that's what I did right here to get rid of the squared, whenever I take the square root of something squared, I will have two answers. Because 2 times 2 is 4, negative 2 times negative 2 is also 4. Second problem, add 4 to both sides. X squared less than or equal to 4. X square root both sides. X is less than or equal to plus or minus 2. You say, wait, how does that work? This is where we're going to have to then be thinking about a number line. Here's negative 2. Here's 2. And think, when 2 is up here, when I'm greater than 2, when x is like 3. 3 squared is 9 minus 4. Is 9 minus 4 less than or equal to 0? Yes, it's a negative number. It's going to be shaded up here. If I pick a number in the middle, 0. 0 squared minus 4. Is 0 minus 4 negative? Oh, wait, sorry. It's not up here. What am I doing? Get rid of that. 3. 3 squared is 9. 9 minus 4 is positive. It's not 0. I was looking at the wrong symbol. I was looking at that one over there. 9 minus 4 is 5. That's not less than 0. So this area up here is not shaded. So then I've got 2. 0. 0 is in between here, between my two values of plus or minus 2. 0 minus 4 is negative 4. Is that less than 0? Yes, which means I'm shading in between. I get to negative 2. I also know there's a closed dot there, but then if I get beyond negative 2 to like negative 3, negative 3 squared is positive 9. 9 minus 4 is 5. Is 5 less than 0? No, it's not. So my final solution on this ends up not being this. It ends up being x less than or equal to 2, greater than or equal to negative 2. So it's kind of like when we worked with absolute values in the past. Because I cannot be less than 2 and less than negative 2 at the same time. When I take that square root, I'm taking this symbol, flopping it to the other side in the same direction, just like we did with absolute values. And I'm putting the negative value at the left end. And it's just not a bad idea to always check it with a number line. X squared greater than or equal to 4. X plus or minus 2 again. It's greater than or equal to, so it'll be x like this, which actually doesn't make sense because it's not between. If you would graph it, negative 2, it'll be down here because it's x less than negative 2. And then it'll be a positive 2, closed dot, shaded up here because it's x greater than positive 2. So in this case, it'll happen either below negative 2 or above positive 2. For this one, it happens below positive 2 and above negative 2. I say and because I can be between both of them. This is or because I'm either here or there. I cannot be and in this scenario. I cannot be greater than 2 and less than negative 2 at the same time. But when you think about the equation, when's this equation negative? When's this equation positive? You can't be both positive and negative at the same place. Back to where we started with the first couple problems we worked on today. Last equations, these back here. We did all of those in Desmos, graphed them. So again, based on what you did in looking at those, what effect do each of those variables have? Like what does A do to a graph? What is the H? What effect does that have? What is the K? What effect does that have when I graph these parabolas? And then what we're going to do next momentarily while you're writing that down. But in a moment, we're going to take this and this is in standard form, AX plus BY plus C. We're going to take a standard form and we're going to convert it into general form. So that way I can look at it and go, oh, here's the vertex. Oh, here's how steep it's climbing. Oh, here are my zeros and things along those lines. So what happens if K is greater than 0? What happens if K is a positive number? So plus a positive number, what effect does that have on the graph of a parabola? It shifts the parabola up. All right. So then you'd be like, all right, well, if this number is a positive, so if it's plus a positive number, my graph gets shifted up. If it's adding a negative number, so if K is less than 0, it's shifting my graph down. Here's the one that gets kind of tricky. If H is greater than 0, so it's X minus a positive number. So X minus a positive, all right, it's a positive number. How does that shift my graph? So it's going to be like X minus 2. That shifted my graph to the right 2. So if H is positive, it shifts to the right. If H is negative, X minus a negative 2, well, minus a negative would be plus a positive. So if H is less than 0, it's shifting to the left. If A is greater than 0, now we didn't graph one where A was less than 0. If a is greater than 0, like +1, +2, +3, all of my graphs were opening up. It was a parabola that was like this. It was a U going up. If a is less than 0, so if a is a negative number, I have a parabola that opens down. And then there was another category that I didn't write down here that you should be writing down in your notes and having just, so that to yourself you go, okay, I know what that means, is as a gets larger and becomes a bigger and bigger number, the parabola gets steeper and steeper. As a approaches 0, so if a is getting close to 0, so a close to 0, like if a equals 1/10, that's getting close to 0. That means I'm going to have a parabola that's really wide. It doesn't go up very fast. So if you're thinking of that U, if a regular parabola is like, I'll just sketch, if that's a regular parabola, a 1/10 parabola is going to be like this. Much broader. Not as steep of a U. But now what we're going to do in order to get this into general form, we are going to, you guessed it, complete the square. I'm going to add 12 to both sides. So I get all my variables by themselves. I take that middle variable number, that 4, right here. I'm going to take half of 4, which is 2, square it, add it to both sides. I will have 16 equals, and now I'm thinking, how does that factor? X minus 2, x minus 2, x minus 2 squared. Oh, my y is still over here, by the way. Y plus, right there. I just forgot to write the y. Plus 12 plus 4. So y plus 16, and then I'll rewrite that as y equals parentheses x minus 2 squared minus 16. Because I just subtracted the 16 from both sides. My vertex of my parabola is at the point 2, comma, negative 16. Because this would be a positive number, x minus a positive. You're looking at that and all of you are saying, but it's not, it's a negative. That's why I said just think, what makes this 0? 2 does. So it's 2 is the x value of the vertex. The 16 shifts it down, which is negative 16. So this is my parabola, that's the vertex. If I were to go to a graph, I would just go to a real quick graph, like I'm at positive 2, negative 16 is way down here. My graph is going to open up. And the other quick number I can look at, here's my original equation. I can find the y-intercept. It's much like it is on a parabola. Or sorry, on a linear equation, mx plus b. When it's in standard form, which is this is general form, this is standard form. In standard form, if I put 0 in for x, 0 minus 12, at negative 12, right there, 0, negative 12, that's where it crosses the x-axis. Goes up like that. If I could factor this into two numbers that multiply to negative 12 and add to negative 4, x plus 2x minus 6. This is why we do factoring. Negative 6 times 2 is negative 12. Negative 6 plus 2 is negative 4. So at 6, when x is 6, and x is negative 2, that right there is negative 2. That right there is positive 6. So at 6, comma 0, negative 2, comma 0, those are my x-intercepts. So factoring finds my zeros, finds my x-intercepts. Putting it into general form finds my vertex. and then putting in 0 in when it's in standard form finds my y-intercept. Let's try another one. Subtract 3 from both sides, so y minus 3 equals negative 4 x, we'll do that in a second, negative 4x squared plus 4x. I want my first coefficient to be a positive, so I'm going to take a negative 4 from both. It'll be x squared minus 1x, which we oftentimes don't write minus 1, but I'll just leave it there. And this equals y minus 3. Here's where it's going to get a little trickier now. I'm going to take half of the middle number, so half of negative 1, which is negative 1/2, square it, positive 1/4. So on the right side, I'm going to have negative 4 times x squared minus x plus 1/4. On the left-hand side, though, I'm not adding a fourth, and here is why. This 1/4 that I'm adding over here is inside the parentheses, but overall, this whole parenthesis set is being multiplied by negative 4. So on this whole side, I'm actually adding, and now if I were to multiply this out, which I'll do here in red quick off to the side, it would be negative 4x squared plus 4x minus 1. So if I did distributive property, negative 4 times here, negative 4 times here, negative 4 times there, what I've actually added to this entire side over here is I've subtracted 1, even though I added a fourth inside. So that's the complicated part when I have a leading coefficient that's 1, it's a negative number, and 2, it's a larger number. So instead of 4 or 1/4 I'm actually subtracting, because it's a negative, 4 times a fourth. So on the left-hand side, I am going to subtract 1, because that's what it would have been over here. Whatever you do to one side, you do the other side. But on the right side, I now have negative 4 times x minus 1/2 squared. Over here, I'll have y minus 4. How do I know this is minus 1/2? Two numbers that multiply to positive fourth add to negative 1, but it's also half of b. It was the minus 1/2. Finishing it up, I'll have y equals negative 4 x minus 1/2 squared plus 4. My vertex is at the point 1/2, comma, 4. What makes this 0? 1/2. This is the 4 shift up, so it's 4. This is a negative number, which means the whole thing is opening down, and it's going to be pretty steep. If I could factor this original equation, I'd be able to find the two zeros. Going to do another one. Again, cranking through a couple here pretty quick. Y plus 3 equals x squared minus 2x. Half of the middle number, so half of negative 2 is negative 1. Squared is 1, so I'm going to add 1 to both sides. Y plus 4 equals x minus 1 squared. And again, I'm skipping the step where I did this. Two numbers that multiply to a positive 1 that add to a negative 2. Y equals x minus 1 squared minus 4. My vertex is at the point 1 comma negative 4. If I look at my original equation, put 0 in, 0, 0, negative 3 on a graph at 1, 2, 3. That's where it's going to intersect the y-axis. At 1 comma negative 4 is my vertex. A parabola is symmetric, which means that this point can be reflected directly over that one to right here. and it's going to go up there. It's about time. I had a couple more questions that I wanted you to give a try in class that we're not going to have time for. Many of these come off of the Check Your Understanding problems. Those are the ones that are on your Check Your Understanding page for today that you're working to get done by the next time we meet. For 8.5, when I say using Desmos, that's what I really want you to do. Don't do these by hand. Look at these problems, put them into Desmos, sketch the graph, and we're looking for patterns because that is the study of mathematics. See you next time.